Welcome back to my channel. In this tutorial I'm going to talk about differential evolution optimization and its implementation in Python. Optimization algorithms play an important role in various fields including machine learning, engineering and finance. Differential evolution is a powerful optimization algorithm designed for global optimization of real-valued functions. In this blog post, we'll explore the basics of differential evolution and demonstrate its application on a specific function using the SciPy differential evolution function in Python. This tutorial covers understanding the problem, differential evolution implementation in Python, conclusion, and source code listing. We'll start by loading the required libraries. Here we use NumPy, SciPy, Matplotlib libraries. We'll start creating the objective function to optimize and visualize it in a 3D plot. In below code, we will define ranges and function in a mesh grid, then visualize it in a plot. Here we defined the XY ranges and we created a mesh grid. Then we defined our objective function here. Then we plot the surface in a 3D scatter plot. Here I selected simple surface to understand the process easily. Our task is to search a global minimum of the above function in a given range. Differential evolution is a population-based meta-heuristic search algorithm to find the global minimum of a multivariate function. It's a kind of evolutionary computing algorithm that starts with an initial set of candidate solution and updates it iteratively. SciPy provides differential evolution function for implementing differential evolution, and we'll use it to find the minimum of a given function in this tutorial. The function requires search bounds and a callable objective function. We'll define a function without changing the formula above. Here is the callable function, and we'll set the variable bounds that can be specified by defining the max and min values. Here is minimum is minus 4 and minus 4 to 4. Next, we execute the differential evolution function with a given objective function and bounds. So you can print the result, and the result shows the minimum of the function is located in a point of 0 and 0. The result contains the following attributes also: the value of objective functions, the number of evolution, and the number of iterations, and etc. To print an evaluate function at every iteration, you can set true to this parameter as shown here. And you can see all of the steps in here. Now we can visualize the detected minimum of a function in a 3D scatter plot. First, we'll get the results, optimal points from result, and we extracted that value also. Then we visualize it in here. And this is the detected optimal point. In this tutorial, we briefly learned how to use differential evolution method with differential evolution function in Python. Differential evolution is a versatile optimization algorithm suitable for various optimization problems. Here is the source code. I'll put the link to the source code in description. If you like this video, please consider subscribing my channel and hit like button. Thank you for watching, and see you next time.